This is an introduction to solar for electricians. Now, in this video, I'm not going to be covering any specific code. I'm assuming you're a licensed electrician, you have your code book, you've done all your training. What I'm going over is industry-specific information you need to know if you're going to be repairing, servicing, installing, whatever, solar panel systems. The inspiration for this video came to me after I had several different phone calls from great electricians asking basic questions about solar. My goal is to give you a thorough exposure of all the intricacies of the solar industry. The one thing that I learned the hard way is that you don't know what you don't know. And when you're getting into something new, you'll end up making mistakes and learning the hard way. So if I can at minimum expose you to what the potential problems are and the different aspects of this industry, from there you would be able to contact manufacturers, do independent research, and figure out those problems before they come up. In this course, we're going to be covering the different types of materials used, the different types of installs, AC versus DC, permitting, net metering, and engineering, as well as a final topic going to be all the lessons I've learned the hard way or seen other people learn the hard way. All right, so the first topic is going to be the material used in a solar panel installation. And I've broken this down to the solar panels, the attachments, the electronics, maybe the inverters, and then also batteries. So buying solar panels can be overwhelming because there are a lot of manufacturers and there are hundreds of different variations of solar panels. The first thing that a customer may notice is the aesthetics of the panels. You can take one panel and another panel and compare them and they may look completely different. On commercial projects, there's panels that are kind of engineered for commercial and for residential the same, and maybe smaller off-grid projects the same. The first thing is aesthetics, color. It's been very popular in the residential market, specifically where I'm at in the United States, to use black solar panels. So solar panels have, in general, a aluminum frame around them. They have, silicon wafers, cells in it, and they have a back sheet behind these cells, glass on the front of them, and then, usually silver bussing or wires. On the newer panels, what they're doing is they're adding a black back sheet. They're doing an anodized black aluminum frame, and then they'll even black out any silver metallic on the top of the solar panel, and then they can actually color sort the silicon wafers and even make darker ones. So there are some solar panels that have just like a clean black aesthetic. If you're looking at more of a value engineered or commercial utility type panel, a lot of those features are just extras. You're looking at a panel that may be blue with a silver frame with a white back sheet, because that isn't necessary. We're just trying to get the most production out of that panel for the least cost. Solar panels come in different sizes. You can buy small ones for, say, an RV, and you can buy massive ones for like utility use. And even when it comes down to, say, a residential solar panel, the width, height, and thickness are all going to be different on panels. A lot of them range from like 30 millimeters thick to 40 millimeters, and they'll range from, to put it in inches, about 66 to like 80 inches tall, and then somewhere around 40 to 48 inches wide. Now, this is all extremely important because when you're fastening a solar panel to a structure, you need to make sure that it fits. And you also need to know that the hardware that you're using is compatible with those panels, and then the aesthetic is going to be what you're looking for that project. Another thing to note, one of the most popular solar panels made is frameless. A lot of these panels on utility sites actually don't have a frame on them, and it's just like two pieces of say glass that sandwich the silicon wafers between them. And so that type of panel uses a completely different bracket and attachment system in order to fasten it for ground mount or to a structure. When you're dealing with solar panels that are different sizes, you're also dealing with solar panels that have different performances. It might be a higher wattage or a lower wattage, or same with the voltage. And when you're designing a solar panel system, you usually have like maximums where you can't exceed a certain amount of voltage on a string or exceed amount of wattage or different things like that. So along with the physical size, you do need to pay attention to all the electrical parameters of that panel to make sure that that will fit with the design of your system. Moving on with this material category or subject that we're talking about, the majority of solar panels that I've installed are on a roof. And essentially what you're doing is you're getting a bracket that is designed for the roof material, the roofing system, whether it's metal, tile, asphalt shingle. There's a bracket that's specifically made to attach to the structure, whether it's the decking or a rafter. From there, generally there are rails that span across these brackets, and then the solar panels will sit on top of those rails and be fastened down with different clamps. With these systems, there's a lot of different accessories for mounting, say, an inverter or an optimizer or a rapid shutdown device or grounding or anything else that is required for your system. Besides the generic residential solar panel installation rooftop that I'm speaking of, the majority of solar panels are actually either a ballasted system on a flat roof or a ground mount for like a utility scale installation. So there is a solution for mounting a solar panel on anything. And there are a ton of different manufacturers who have created and designed their own specific bracket or system for different applications. One thing that I do love about attachments for the solar industry is that the manufacturers who make these attachments have a ton of resources for how these are supposed to be installed, and they even have resources for engineering to make sure that their product is correct for the application that you're doing. So you're able to lean pretty heavily on the manufacturers to verify that your project fits with their product that they've created, or get recommendations from them. Next category is electronics. And when I'm talking about electronics, I'm specifically talking about inverters. That's kind of the heart of the system, is the inverter. And there are a ton of different inverter systems, and there's also a few other electronics that may be necessary in order for the system to work. Every inverter manufacturer has its own ecosystem. It's their own proprietary parts that are all designed to work together. There's several different types of inverters. You have microinverters, which generally live underneath the panel, on the roof or on the structure. You have string inverters that generally live next to the system or on the side of the home. And then you have a string inverter with optimizers or rapid shutdown devices. I'm gonna break this down the simplest way I can because I get overwhelmed, because there are so many different manufacturers that have their own kind of custom system that's like similar but not compatible with other systems. When I'm talking to an electrician who's getting into solar, maybe residential, I generally will recommend a microinverter system, because that system is going to be the most familiar. It's going to be similar to how you wire branch circuits for doing like a basement finish or something like that. My personal preference is to use a string inverter, but you are dealing with DC, high voltage DC from the roof to the inverter. And then with the current rules in my area, you're required to have like a rapid shutdown device or a power optimizer that doubles as a rapid shutdown device under every single panel. So you have what they call module level electronics. But those systems can be uncomfortable at first because you are dealing with series connections and high voltage DC, which may be unfamiliar to you. That being said, not all inverters are UL listed or have the right system to be installed in your area. So you need to make sure that the products that you're installing are like accepted by the local authorities or the power company, and we'll get into that later. The last category that I want to cover is batteries. Over the last few years, the market for batteries has absolutely exploded, and it seems like all of these inverter manufacturers and other manufacturers are making their own battery that is compatible with their proprietary ecosystem of parts. Now, you do have a lot of different types of batteries. You can buy something that looks like a normal 12 volt lead acid battery and put together a bank of batteries, what you're probably picturing for a stereotypical off-grid system. And then you also have these sleek enclosures where there's usually lithium or lithium iron phosphate battery cells all put together, where it's like an all-in-one package, similar to what you may have seen from manufacturers like Tesla. The best recommendation that I could make to you is to try and use the least amount of manufacturers for your project. So the battery, the inverter, the optimizers, or the microinverters, whatever, the whole ecosystem is manufactured by one person, and it is tested to be compatible and work together. That's my recommendation. Now, I have my favorites, and I can pick and choose and kind of custom design a system based on what cool batteries I like, or what, transfer switch or inverter or this and that. But that I would not recommend that for a first time project. Moving on to topic 2, the types of installations. You have 4 main categories. You have grid tied, you have off grid, you have hybrid, and then you have like commercial utility. I'm going to cover each of those 4 and give you a basic summary of those. So the first is grid tied. Grid tied solar panel systems utilize a specific inverter that has been designed to be grid interactive. This system is connected to the utility grid, takes the solar power, and backfeeds it to the grid. And that's what it's designed to do. Because it is backfeeding electricity into the utility grid, the utility will put forward some standards of what inverters, what different listings, what functionality that inverter needs to have in order to be connected to the grid. Now, there's a few things to know. The standard grid-tied inverter does not work when the power goes out. I think that's one of the biggest misconceptions with like rooftop solar, specifically in the United States, is that solar panels, the majority of them, residential, 80, maybe 90% currently, do not have any capacity for backup power. They're merely designed to take sunlight, turn it into electricity, use it in the home, and then export the rest to the utility for a credit through their program. You need to know that when you're setting up one of these systems, you have to comply with all of the utilities regulations and, UL listings, all the standards, the permitting process for, the building department and all of that. The next type of installation would be off-grid. An off-grid system will have an off-grid inverter. Now, off-grid inverters are not grid interactive and can't be connected to the grid. For off-grid systems, your inverter is going to be battery based. The inverter essentially has to have a battery bank. It pulls power from the battery and it changes it to AC and then backfeeds whatever you've set it up to power. And then the solar is kind of like an accessory that is used to charge the batteries. In these types of installations, you'll commonly have like a charge controller and fuses and a few other different electronics that you need in order to make that system work. Recently, as in say the year 2020 moving forward, we've seen a new type of inverter, and it's commonly referred to as a hybrid inverter. Now, this inverter is designed to be grid interactive and comply with all of the regulations that the power company and the building department has for the inverter, but it does also offer some backup capability and some functionality off-grid for supplying the home for backup power. Now, these hybrid systems do require basically redundancy. You have a lot of the electronics you need for an off-grid system and a lot of the electronics and materials you need for a grid-tied system. And you may see some additional things like disconnects and transformers and transfer switches and a lot of different things you need in order to make these systems work. And then the last category I want to talk about would be like the commercial and the utility side. Now, in the United States, generally you have, say, single phase 240 for a residence. When you go into utility and commercial, a lot of times you'll have 3-phase and whatever type of 3-phase. Inverter manufacturers design inverters that are specifically made for that application. And you might see inverters that have, higher voltage ratings on the DC side, whether you're not dealing with like 600 volt like residential. You might be dealing with like 1000 volt or 1500 volt and larger inverters with larger strings. But in general, it doesn't make sense to take a residential or an off-grid electronics and try to apply that to commercial. There's specific systems made for commercial and utility where the price point makes more sense, and a lot of those products are like custom ordered and on back order, so that needs to be planned out in your project. So topic 3 I want to cover is AC versus DC. This is one of the most common subjects that I have coming up with new electricians going into solar. When it comes to AC and DC, you have the two inverter types: microinverters, string inverters. Kind of summarize it down to that: microinverters, string inverters. Microinverters plug into the back of the solar panel, generally on the roof, and then from the microinverter you have 240 volts AC and you have parallel connections. Now, when you're doing a string inverter, you're going to plug solar panels negative to positive together, doing series connections of high voltage DC on the roof that goes down into the solar input on the inverter. So you have these two completely different systems. High voltage DC system, that's series connections, and a kind of a low voltage DC parallel connection AC system where you have AC coming from the roof. This absolutely can be confusing and it can be dangerous, and you can have a system that isn't operable and even the equipment is damaged if you mix up these different types of connections. So with a generic residential string inverter, you'll have like a cap of somewhere between 500 and 600 volts DC. Each solar panel now is 40 to 50 volts. So if you're doing series connections, the voltage is additive, and you can put maybe 10, 11 panels together in a string and then run that down to the inverter. And then at the inverter, generally the inputs referred to as the MPPTs, they'll have a parallel connection at the inverter if you're combining strings. With microinverters, most of these microinverters put out just over 1 amp at 240 volts. Single phase 240, 1 amp. So when you're doing parallel connections, generally using a pre-made cable, your amperage is additive and your voltage is fixed. And you'll generally have about 10 solar panels, maybe more depending on your system, on a circuit, because you'll probably be doing somewhere around a 10 to 20 amp circuit, and then running that AC down to a combiner panel. Now, if we're transitioning the subject over to batteries, a lot of the batteries that are all-in-one enclosures will be more of a high voltage battery. They might be somewhere around the 50 to 80 volts DC. But most of the off-grid inverters and even a lot of the hybrid inverters, they'll have batteries where you're just using, like, say, a 12-volt battery. Now, the input on these battery systems may be 48 volt. And so if you have a 12-volt battery, you're going to be doing a series connections of 12-volt batteries, 4 of them, to get 48 volts. And then from there, you're doing a parallel connection if you're adding, more kilowatt hours to your storage. If we're looking at the battery connections, we're looking at the solar connections, and we're specifically talking about DC, this is one thing that you need to keep in mind. High amperage, low voltage DC, high voltage, low amperage DC. You're running generally like 12 gauge, 10 gauge, 8 gauge, somewhere in that range, depending on what you're doing on the roof for these 500 volt strings. Now, when you're going over to batteries, you might have a 12 volt or 24 volt or 48 volt battery system. And in those situations, you're looking at high amperage, like 200 amps, 400 amps, and you're using a very large wire size, and you're generally crimping on different connectors and using heat shrink and making sure that those connections are really secure. So when you're dealing with DC, those kind of are like two totally different systems using different wiring, different wire sizes, different terminations. Another common thing in the industry when you're looking at battery systems, whether it's off-grid or hybrid, is you'll have what's called DC coupling or AC coupling. And that's when you're integrating the solar panels and the battery. Now, first, let's talk about DC coupling. A lot of these inverters will have multiple inputs where you have a DC circuit from the solar to the inverter, and then you have a DC circuit to the battery. And the power can kind of flow between the solar panels and the battery before that electricity is converted into AC and then used on the load. So some of these new hybrid systems are AC coupled. And basically what that means is that the battery has its own inverter, and it's like designed as a standalone system. And so you have the solar, it has an inverter, the battery, it has an inverter, and then you have AC flowing to maybe a combiner panel or a backup panel. All right, let's move on to topic 4, permitting, engineering, and net metering. When you're doing a grid-tied system, residential or commercial, you need to basically get 3 approvals in order to start your project. And I see a lot of different situations where people get into trouble where they start the project before they have permission or they have the system designed to the standards of these, 3 groups. First off, what I would recommend doing on any solar project is to get engineering. And I would get electrical engineering and I would get structural engineering. The solar panels are going to be rooftop. You need to make sure that the structure is adequate to have the solar panel fixed to it. And then with the electrical engineering, I can't stress enough to get a experienced electrical engineer to put together a high quality plan set for you. So that way, when you're designing the system, you make sure you have the correct amount of solar panels on a circuit or a string. You have the correct wire size or type of wire from the solar panels to the inverter. And all of those little intricacies that will be put together in a quality plan set. The second part of that, along with the electrical and structural engineering, is maybe your own personal design. There's a lot of different companies out there that have software designed for, placing solar panels on a structure, or even placing the electronics on a wall and kind of putting that design together. But you need to make a visit to site, and you need to do a very thorough site visit. That way you can check and make sure, okay, I have room for my equipment here. I have room for my solar panels here. And then you can check for other things that may be red flags that would cause issues with your project. I'll go over that a little bit more in the final category, but you do want to make sure that you have the right clearances, or the other electrical done on the project is up to code, and you're not going to have issues integrating the solar panel system to the site that are kind of irrelevant to your project, that then become your problem. Once you have those plan sets, you'll need to submit those to the building department for the area that you're working in. Every single building department is going to have their own rules. They may require you to have a separate production meter, a specific type of disconnect, labeling. There's a few different things. In general, they will take the plan set, they will approve it, and then make sure that your install was installed exactly how the plans told you to install it. Now, if you submit it to the city, they may come back and ask for corrections. They may say, hey, we want a production meter and a knife blade disconnect, and we want it here. And then you'll have to make those adjustments and then resubmit it to the city. Now, you also need to, if you're doing net metering, submit you need to submit your project to the power company. Now, this can get a little bit frustrating because the city and the power company, the building department and the power company, don't necessarily have the same standards, and their standards might even be a little bit redundant or conflict. But you got to make sure that your project meets both of those standards, because you need it to pass the building inspection, but you also need it to pass the power company's requirements and possible inspection. The utility will have a document on their website, usually called a net metering agreement or customer generation agreement, and it's going to be a lengthy document that outlines all of the requirements for a solar panel system. Maximum size of system that you can have, the maximum amount of panels, the disconnects required, how much they're willing to compensate you for electricity that is exported to the grid, if they'll compensate you at all. They'll outline the whole rate schedule, and if the system's large enough, you may even need to do a review to make sure that the transformer is adequate for the additional production from the solar system. This is topic 5. It's the final for this course, and it is lessons I've learned the hard way. These are the top 10 mistakes that I've made and I've seen other contractors make. I hope that with the summary of the industry that you have a good overview and understanding of how these systems go together and how they actually go in. And with these important mistakes that other people make, you will be able to know what you don't know and not have to learn any lessons the hard way. That way you have a profitable business and a happy customer. The first one on this list is that the solar industry is volatile. I hear a lot of people refer to the solar industry as the solar coaster. And my personal take on this is the majority of solar installations in my area and at this time have been grid tied. And those systems are sold as, you can't afford your electric bill, buy solar panels, it'll save you money. That's kind of a jaded perspective, but that's a very common perspective on the sell side of things. And when the power company does change the agreement they have, say the export credit, how much they're paying you for the electricity you're giving them, or they just say no solar, or they put a cap or anything like that, the solar industry hurts really bad. And you'll see a lot of companies bounce around to hot markets or get bought out or go out of business, kind of come and go. And so that's kind of the first caution that I would make. And my hopes, I've seen a lot of sales organizations sell installations and try to figure out the install process. I think that might be a little bit of putting the cart before the horse. I would hope to have more qualified, experienced contractors and electricians get into solar and do solar the right way, have extremely high quality installations that are all to code and going to last a long time, and then kind of figure out the sales side of things later. And I think that is a much more sustainable model. The next category is going to be transformer upgrades and service upgrades. A lot of times when you retrofit an existing building, electrical structure with solar, you will need to do a main panel upgrade. And worst scenario, you may even need to do a transformer upgrade. And so this is very important during your site visit, your personal assessment of the site, your engineering, and your net metering with the power company, that you make sure that those costs are factored into your estimate. Because I've seen people go to install solar, fail inspection, have to do a service upgrade, have to eat the cost of that, or a transformer or something like that, and they end up losing money on the job. The next item is make sure all the existing electrical is to code on the structure you're installing on. I see a lot of situations where the air conditioner's been replaced, hot tub's been added, or the building is really old and the clearances aren't there, and then you run into issues when you install stuff and you open up panels and you see something that's not good. In order for your system to pass inspection, you need to get those other things taken care of. Another thing to watch out for is other work on the house that has not been permitted. Seen a lot of situations where maybe a deck was added to the house, or an addition or a basement was finished, and during the inspection for that specific situation, that comes up as, hey, this is here, it's not permitted. In order to pass the inspection and everything closed off for the solar, you need to file a permit for the deck that you put on your house that you didn't permit. I've seen a lot of contractors in weird situations like that have to eat the cost, or with a homeowner that's not willing to work something out. Solar loans, solar specific financing is tricky. Something that's universal, specifically in the United States, is massive origination fees, which are essentially prorated interest, like bought down interest points. I'm not a financial advisor, but I would love to tell you what I know about this. In general, you'll have a solar loan and you'll need to pay a percentage of that loan up front to the lender in order to originate that loan. And I'm seeing fees somewhere between 10% and 30% to get this 20-year loan at 3% interest or whatever it is. And I've seen a lot of contractors not know that those fees are there, and they sell and install, they do it, they finance it, and then they literally have to pay money to do the job because they didn't price the system, in order to cover that additional 10 to 30% in cost. So there are other financial vehicles in order to sell a solar panel system that don't require origination fees. You might have options for home equity line of credit, or maybe even like some kind of PPA or something like that. But though, that's something that you need to understand, is if you're financing these systems, you need to make sure you know the terms of the lender. I want to bounce back over to net metering. What I've seen in my area over the last 10 years, going from no solar installs to pretty popular, is that the agreement with the power company, the largest company in the area, has changed over time. When I first started installing solar, when you exported a kilowatt hour to the grid from your solar panel system, you were compensated a kilowatt hour from the power company or its value. Currently, the export credit has been reduced down to, say, 30% of the value of a kilowatt hour. In that situation, you would need to install an astronomical amount of solar in order to give them, say, 3 kilowatt hours for every one you use, as an example. So if you're looking at solar for net metering as a financial investment, offsetting your electric bill, that agreement with the power company is going to dictate how the system's set up, and it could even change. Some of these agreements only have a certain lifespan, and then after that, I don't know if I even have an agreement with the power company, kind of situations. I think battery storage these hybrid inverters with battery storage is becoming a lot more popular, because you can self-consume more of the electricity that you're producing, having that power go to the battery and then being consumed at night. Although to be honest, it's extremely expensive and hard to do, to get a basic kind of off-grid 100% self-consumption system set up with how much power houses use and how we use our electricity. And then on top of that, a lot of utilities have really complicated rate schedules where they have time of use, where electricity costs different at different times, or demand charges based on the maximum amount of power you used in a different period. And so you really need to look at different softwares, make sure that your design is, correct for the utility and the net metering agreement that you're working with. Or you may install a solar panel system and tell the customer that it'll offset their electric bill, and then it doesn't. Let's talk about product defect and failures. Over the last 10 years installing, there's been some very large, reputable manufacturers that have had large quantities of products fail. A lot of the manufacturers will warranty or send out replacements. It's kind of a pain to request that warranty, and it takes time to go to site, examine, take photos, submit, receive, go back to site, replace. That whole process can take a lot of time. And this is something that's kind of common in the industry, is you have product failures. If you have an off-grid system where that homeowner is using that power and needs that power for their homestead or whatever it is, redundancy, like if you have an inverter fail or a connector fail or anything, you need redundancy in that situation so they have backup for their backup. Residential, if you have product failures, you need to kind of factor that into your pricing and your warranty in your contract, that if you're 8 years later after you installed the system and a part breaks on it, how do you respond to that phone call? Is it warranted? Did you say it was warranted? Are you sending someone out for free? Are you charging? Are you able to do that? Really look at those situations. Done a lot of troubleshooting and repair jobs where there's been situations like this that were more along the lines of acts of God that were outside of the warranty. One I see all the time is golf balls. Like someone lives on the golf course, golf ball hits the solar panel, breaks it. 5 years later, you can't buy that solar panel. That panel cannot be replaced. And the retrofit is actually pretty hard to figure out. Situations like power surges, whether it's from the utility or it's from, like, say, lightning striking utility equipment, whatever it is, a lot of solar panel electronics don't have surge protection in them, and they could potentially be fried by the grid and not covered under warranty. You have situations like roof leaks, where if the equipment wasn't properly installed, or if the product's even defective. I've seen, manufacturers go out of business who made attachments, and their attachments were faulty, defective, and they had structural problems and roof leaking. That's something that you need to carefully consider when you're, putting together your pricing and selling these systems, and doing research on these things. Thermal events. High voltage DC is pretty dangerous, and you can't turn off the sun. And when you have a bad connection or a failure with a high voltage DC system, sometimes you have arcing and light voltage, and some situations that may be kind of like high stress. And so when you're installing a solar panel system and you're doing a string inverter, you need to be very careful that your electrical is clean. You're doing things like using the right PV connector. You're doing high quality conductor terminations. You're making sure you have all the required DC isolators or fuses or rapid shutdown devices or disconnects. All of that safety in solar and battery situations is very important. If you're doing your own off-grid system or an off-grid system, it's very important that you have some kind of means of shut-off or some kind of safety procedure for the system that the customer knows about, and is set up in these kind of emergency situations, whether it's something as crazy as a unassociated house fire or something like that. I'm located in Salt Lake City, Utah. We have a pretty harsh climate where we get a lot of snow and rain, and then we get a lot of heat. I see a lot of solar panel systems fail because of water, ice and water, whether it's attachments are leaking on the roof, whether it's water inside the conduit, water in the inverter, water in the junction box, whatever that is, water is the death of solar. And so you need to be very careful on how you're running your conduit. If you're a residential electrician, you probably know that any kind of outdoor receptacle is a nightmare to troubleshoot, and usually something that fails first on a home. Outdoor lighting, things like that. And so solar panel systems are outdoor, exposed to the elements, and so you need to make sure you're using high quality materials and industry best practices so that lasts for a long time, and you avoid the liability of house fires, roof leaks, the crazy things that can happen in this industry. Man, I think that sums it up for me. I appreciate your viewership. I appreciate you going through this course. I am hoping that this information really is helpful to you to get a basic overview of the industry and to avoid making mistakes that others have made. I love the solar industry. I love solar technology, and I really want to push for higher quality installations that last longer. And I think we need to rely heavily on experienced, qualified contractors that can bring a lot to the table and take this industry and push it forward. Good luck.